Hi folks, so the question we have here in front of us today, guys, is from page 11 of the DCG workbook, Plane Descriptive Geometry. It is based off of the auxiliary section, so it is, okay? And today here you can see we're faced with this little hexagonal based pyramid here. And what we have to do is we're given the elevation, we're also given the plan view of the structure, and what it says is shown as a pictorial view of the hexagonal pyramid. So we can see the pictorial view here, the front elevation and plan are given, and what we have to do is project an auxiliary plan in the direction shown in order to show the true shape of the surface A. So we can see the surface A is here, this is the surface A here, that surface there, okay? And what we want to do is we can see the face A is this face here, we can see it down here in plan. And in our elevation, we're seeing the face A, which we see in plan. In our elevation, we're seeing it as an edge view. Okay? So anytime you want to see the true shape, you have to look perpendicular to that face. Okay? So what we're going to do is we're literally just going to project down perpendicular. Our x1, y1 is already set up. And this is actually what would be known as an auxiliary plan. Okay? Whereby we're going to project down perpendicular to the face in elevation, but take our depths from the plan. Okay? So what I'm going to do is I'm going to set it up, my x1, y1. And then I'm just going to rotate it down. It's all been labelled for us already. Labelling is very important. So I'm going to project down points 5 and 6. It'll be down there somewhere. Same with 4 and 1. And then 3 and 2. And then the last one, 0 at the top. Okay? Now, this is not too hard, it's just a case of understanding, alright? You have to remember that our x1, y1 is technically a plane that is coming up out of the page like that, okay? And obviously then, for our sakes, we're obviously doing it on a 2D flat surface. That page is kind of obviously down the sheet, so we're trying to draw it on that. So the idea is that the page is up here, and as we look in it, it's projected onto that surface, okay? So, what I'm going to do is I'm going to take my depths down. Now, just to get the depths more accurate, oh no, I should actually be fine there, I just realised, sure. So what I'm going to do is I'm going to take the distance, okay, I'm going to start with 5 and 6, okay, I'm going to take the distance for 6, which is there, which we can see is the same as 2, okay, so what I'm going to do is, for 6, I'm going to follow 6 out to where it hits my x1, y1, mark out the point, the exact same, because it's the same for 2, I would label them once again, so I'll just label them, so that's 6, that one there is 2 at the back. Okay. Now I'll do the same for 5 and 3. So 5 is here, 3 is here. And now I want to do the same for 1 and 4. So I'll start with 4. 4 will be all the way out here. It's right at the edge. Make sure I'm in the exact position, and then 1, so that distance there, make sure it's accurate, mark out 1, okay, so you can see then we have 1, 2, 3 at the back here, 4, 5 and 6, and the last one then we have to find is 0, so from the XY line down to 0, okay, it's always the XY line, unless you set up a different datum line. Okay, and 0 was up here, project it down. Now we have 0. Okay, and at this point now, what I'm actually going to do is I am going to draw in the actual true shape of the face A first. And if we look, A is 0, 5, 6. Okay, so that means we can see the true shape of that because it's at the front. So 0 there, down to 6, also down to 5. Okay, and we'd see this bit here at the front as well. There we go. Okay, so that is my face A there. Just going to write that in. Face A, true shape of face A. Alright, now at this point I'm going to see, I would see around, because as I'm looking in, I'm technically kind of looking in from this side here at the moment, obviously it's at an angle to it, but I would see maybe a little bit of 0, 1, 6, and I would see 0, 5, 4 as well. It's these faces at the back, 0, 1, 2, 0, 2, 3 and 0, 3, 4 that I probably wouldn't see, okay? So having in those, and I know they all connect up to 0 at the top, that's kind of what we will see right there. Now that's kind of what we see. The Question is not done, however. At the end of the day, this is an orthographic projection, so you should show hidden detail. So I know the base is hexagonal, so I need to finish off this bit here. So hidden detail here at the back. 3 connects up to 2. Once again, hidden detail, and 2 connects over to 1. And obviously then 3 connects up to 0. Once again, a bit more hidden detail. And then 0 down to 2. Okay, that's the question completed there. What I would usually do at this point, guys, is I often find it's quite helpful to use a little bit of colour. So I'll just grab the colour here now, nice and quick. And I just find the colour just gives us a little bit better of an understanding of our work as we're doing it. Okay, so just shade in this little area here now. So just on the true shape, what I would usually do is I would shade in that there. Okay, and basically telling the examiner or anyone who's correcting the paper that you have found the true shape of the surface that they were looking for. Okay, so that's nice and easy there. I'll speed up the video. Right, folks, so the next question we're faced with here today on this page is question number 2. It says, shown is a pictorial view of a solid. So we've got the solid here. Okay, the front elevation and plan are given, and construct a view that shows the true shape of the surface A, B, C, D, E. Okay, and we can see it's labelled up here as well. What view is produced? An auxiliary plan or an auxiliary elevation? Okay, the answer to that is it is an auxiliary plan. Okay, because we are projecting from the elevation, but we're taking our depths down from the plan. Okay, so what we need is we want to basically get the true shape of this cut surface over here. We're trying to get the true shape of this surface over here. So if I just follow on their labels there, if I follow their labels that they did, they have A here, which would be in this position. Then I have B, C, and so on. So B is there, C is there, D, and E. Okay, A, B, C, D, and E. And essentially what we have is we have a plane that's cutting that at an angle. Okay, but what we want is the only way we can see that as a true shape is by looking in perpendicular to it. You have to look in perpendicular to it. Okay, so what we're going to do is we're going to set up an x1, y1 parallel with the cut face. Okay, and then what we're going to do is we're going to project up perpendicular to that and get our true shape. So first of all, set up an x1, y1 parallel to the cut face. Okay, x1, y1. Okay, and after I do that, what I'm going to do then is I'm going to project up my points perpendicular to that. I'm going to start with A, B, C, D, and E just, and then I will finish the rest of the shape as well. Okay, so E is up there, depending how far I have to go. A doesn't seem to go as far, it's just up to there a little bit. D is the furthest, and then we have C and B. Okay, now at this point I projected from the elevation, I take my distances from the plan. Okay, so from here I'm going to mark E first. I'm just working my way backwards then along it. So there's E, come to where E hits the x1, y1. That technically would be now known as E1. Okay, x1, y1, E1, so forth. Okay, now I'm going to do A. Come to our A's. Then I'm going to do B next. So come find B. Then I'll do C. And the last one then is D. Take that distance there from the XY line. Then from D here. There we go. Once again, labels. So that was A1. This is B1, C1, D1. Okay. Join them up. And that there, guys, is the true shape of the cut surface, okay? Now what I'm going to do here now is, we obviously know there's a little kind of triangular bit here at the top, and then there is 4 faces going around the outside of it as well, because if you look down on top of it, we can see that it's a square, okay? So basically what we have to do is we obviously have to find where those points are on the ground as well, okay? So we've obviously got a point here, a point here, a point here, and a point here, okay? And we've also got one more point up here, okay? So once again, just to be able to complete the whole structure, okay, what I'm going to do is I'm going to project up all those points as well, okay? So sliding set squares, the point here, I'll use different labels for them in a minute. So got a point there, and sorry, skipping by it, point here, and then point here, and then the last one is a point here, and has to go a little bit further, and then the very last one, just have to extend it up, move my set squares a little bit, so I'll be able to reach this one here, okay? So the exact same process, just going to use different labels. So for the ground, I'm going to say it's numbers. I'm going to say 1, 2, 3, 4. Okay. So this point here is 1. I'm going to call this one 2. This one I'm going to say is 3, and this one back to 4. So if I was to follow it, look on the ground, 1. I'm going to say this is 2. This one is 3, and this one is 4. Okay. And then I'm also going to call this top point here F. Okay. So F is up here then. All right. So stick with the letters on the top, the numbers at the bottom. So what I'm going to do is locate the points on the bottom, starting with 1. Okay, 1 is there, and 1 is here, so I'm going to mark out where 1 is. It's the same distance as where E was. Okay, then the exact same for 2, which is the same as A. And find where 2 was in my elevation, project it up. There's 2. Same for 3. Find where 3 was. Okay, and then the last one for 4. There. And 4 is out here. So I have to need to massively bring that up there. So project that up as well. One needs to go up a lot higher. 4 is up there. Okay, and then the very last one I had was F, which was the same distance as 3. And F was out here. There we go. So this technically is F1. And now using numbers, this will be technically 1, 1. And then I've got 2, 1. Then I've got 3, 1. So 3, 1 was here, and just writing it in, 3, 1, and then I have 4, 1. Okay, so looking at that now, just going to start heading in the right parts. So looking down on top of it, obviously when we're looking down on top of it in this direction here, I would see a bit of this face here. Okay, so I'm going to, this bit here is going to be heavy, B to F, B1 to F1 I should say, F1 back to C1. Okay, and then I'm also going to see a little bit of the outsides. I'm going to see from 1 to 2, and I would see from 1 to 4. From 2 to 3 and 4 to 3 I probably wouldn't see though. Okay, so 1, 1 to 4, 1, technically yes. 2, 1. Okay, I know 1 also connects up to E, 2 connects up to A, and 4 connects up to D. So 2 connects up to A, 1 connects up to E, 4 connects up to D. Okay, and now at this point then we can see 4 is going to join back to 3, but that's going to go in as hidden detail. And then 3 also will connect to 2. Make sure that's in the correct position. Yes. Okay, 3 will connect to 2, and we can see then 3 at the back connects up as far as F, so a bit of hidden detail there as well. Okay, that's the question done there, guys. Once again, I'm just going to shade in the cut surface so it gives you a little bit of kind of better understanding of it. So speed up the video there now as I'm shading it in. Right folks, so the third question we actually have on this page is where we are given the elevation and we're given the completed auxiliary view, and what we're actually going to have to do is we're going to have to work backwards to find the actual original plan view. Okay, the other two questions that we've already completed on this page is where we are given the elevation views of the the orthographic views of the elevation and plan, and we had to find the auxiliary. Okay, this time we are given the auxiliary and the elevation and working backwards. Okay, so it says shown as pictorial view of a hexagonal prism which is inclined to the horizontal plane. Inclined meaning basically it has been tilted off the ground. Okay, the horizontal plane being the XY line, and that is our ground line. Okay, now the front elevation is given above, also given as auxiliary plan. Okay, that shows the true shape of the surface ABCD. Construct the plan of the prism. Okay, so what they're basically telling us here is, I'm just going to speed up the video here now, I'm just going to shade in a little bit here. Okay, so I'm just going to speed up the video there a second. Okay, what I've done there guys is I have coloured in the surface ABCD, okay, and if we look up here to our elevation view, we can see ABCD is actually an edge view. So technically what they have done here is they have looked in this direction perpendicular to the face to get an auxiliary plan down here. Okay, and what they have done is basically they've looked in perpendicular to this face here, which is an edge view. Okay, that face there we see it as an edge, whereas in this view down here, this view, we see it as the true shape of that face. Okay, what we're going to have to do is we're going to have to work backwards. Generally when you project from the elevation, you're going to take your depth from the plan. Okay, we don't have the plan here, but obviously we can take our distances from the x1, y1 here and then work down from the xy line backwards. Okay, so what I'm going to do starting off with, just to give you the idea, is I'm going to locate the points A, B, C, D. Okay, so what we would do there is anytime you're doing obviously orthographic A, B, C, D, A and B, it's going to be directly below it, so straight down, and the exact same with CD, straight down. Okay, don't know exactly how far yet, it's just down there a certain distance. And what I will do then is I'm going to take my distances, we're working backwards this time, and I'm going to take the distance from A, okay, the x1, y1 out as far as A, which is the same distance from the x1, y1 out as far as D. Okay, what I want to do is I want to find those. So where A is up here, follow it down, and where D is, follow it down. Okay, and do the exact same for B and C. Okay, label them. Always very important. So technically that's A, and then I had B here, now I've got C, and now I've got D. Okay, so that actually is a face. I didn't actually have to mark them. If I was smart, I'd only need to mark one and I could have projected the line over, but just showing you that the compass will actually find all the points as well. Okay, you could do a little bit of time saving there. Now what we actually have here, just to show you, we have now found a face A, B, C, D. Okay, we have now found that face, but as you can see, it is very much different to the face over here. It's like it has been squished in. Okay, and the reason for that is because as we look down on top of the surface, okay, we're only seeing an angled view of it. Okay, that's basically what's happening here. Now what we have to do is we actually have to find the rest of the points. Okay, so first of all, what I'm actually going to focus on is this top surface here. Okay, so there's obviously 6 points. It's a hexagonal, or it's a hexagon at the top of it. Okay, so there's obviously 6 points, okay, that we need to find. So I've already found A and B. Now I need to find this point here and this point, 2 points here and 2 points here. Okay, so I'm going to project those down. Okay, project those down. Project this one down. Okay, we'll work on the bottom after that. And the exact same thing then. Okay, I have to take the distances for them. Okay, and one of the distances, if I was just to imagine it was A, B, C, D, E, F. Okay, so if you imagined I had A, B, then I might have C here, and then C would have gone over to D over here, so I'm going to put D at the back, then D would have gone to E, and E would have gone to F. Okay, so we have to work that out. It would have been A, B, then technically we would have had C here, D, that can be kind of hard to understand, guys, and you kind of have to have good visualization and imagination to be able to work that out, even just without doing it yourself there. Even if you didn't do the labeling, chances are you'd be able to find the points here and you would have been able to figure it out anyway. Okay, but now what I'm going to do is I'm going to find F, which is in this position here. Okay, find where F is over here. It's there. Project it down. Okay, the exact same then with C. There's C. And C was here as well, from the same position. Okay, so now I've got F here and C here. And what you're probably wondering is, why haven't I found D and E? But if you notice, E is in the same position as A, and D is in the same position as B. Okay, so technically I could, just to save me a bit of time, from A I could just mark across, and from B mark across. Okay, and what I've now found here is D and E, and at this point now I can actually start to heavy it in. Okay, so I'll just heavy in that little bit there now, because we would see this, it's on the top. There's B, I have to go over my letter a little bit, doesn't matter. And then E. Now, as you can see, I've kind of found the top surface of it there now. What we need to find now at this point is the bottom surface, okay? But at this point I've actually all the measurements taken, so just a little bit of understanding on what ones I can actually transfer across will save me a bit of time. So I'll project down this one, and then the last one here is this one. And that one is sitting on the ground. Okay? So, same thing. From C, it's going to come to the outside, because look, C was down along this line here, so that's going to be on the outside as well. So C is on the outside, so this point here is on the outside, and it's going to be the same with F. Okay, so just heavy in that to help make things a little bit clearer. That's going to be another 2 points. Shouldn't probably have used C there, guys, just forgot I used C here and D here as well, but you get the idea. So that one there, and this one here. And at these points, we know they connect all the way up to the top. So we can actually start to see it there now. As we look down on top of it, that's the kind of view that we would have, where we see the top surface here, then we'd see a bit of the side face here, or sorry, front face, side face kind of. But what we're missing then is the hexagon at the bottom. I have it half done, but obviously we have another bit inside in here somewhere, okay? And the thing is, we just have to be able to finish that off, but it's in hidden detail because we wouldn't see it, it's underneath. So where E is it's all going along these lines here, so just follow it down. So there's my mark there, and then my mark there. Okay, and at this point now I've found all my points. It's just a case of heading in the right stuff. Okay, so this one here, hidden detail, we'll start putting in the hexagon at the bottom. And then hexagon at the top, or the face is going up the side, I should say. Okay, and there we go. So that was it, basically working backwards, guys. Okay, that was simply it there, working backwards. Once again, hope you found that useful, and what we're going to do is we're going to go on to the last question there now, question 4 on the page. Okay, right folks, so it says here, shown is a pictorial view of a solid. The front elevation and plan are given. Project an auxiliary plan in order to show the true shape of the slope surface A. So what they're basically asking us is, we've got a face here, we can see it over here in the pictorial, the slope surface, okay, and that's where we see it in plan here, okay, whereas in our elevation we see that slope surface A as an edge view, okay, and the only way we can always see the true shape, as we've done in a lot of the questions here now so far, is literally by looking perpendicular to that face. So technically what we need to do is we need to look in perpendicular to the face like that, okay, and that's the way we're going to do it. So first of all, I'm actually just going to use a little bit of labeling to help us understand it, as always. So I'm going to start down here, I'm just going to label the pictorial first, and I'm just going to look for the true shape of the cut surface first. So I'm going to label A to B, this one here will be C, D, E, F, G to H, okay? A, B, C, D, E, F, G, H, okay? And what we want to do is label it here now as well. So A is here, this is B, this is C, D, E, F, G and H. And the exact same thing then, if I've labelled it in plan, I need to label it in elevation. So I can see A and H are both on the ground, so they're both in this position. I'm going to put A, H there. Okay, then I've got B, C, followed up, B and C. Then I've got D and E in this position, and then I've got F and G. Okay. Now at this point I'm going to try and find all of those, okay, by using an auxiliary view. Okay, so I have to set up an x1, y1 parallel to that face there. So a bit of sliding set squares. Move it out here. Set up an x1, y1, just roughly thinking where I'll need it. So about a little further out, about there. That's it. Trying to keep it neat and tidy. So that's my x1, y1. Okay, x1, y1. Now, at this point, what we're going to do is we're going to project down the points perpendicular to that face. Okay, so x1, y1. A bit awkward. So just tip it around the other way, guys. Visualizer getting in the way, so we'll rotate it that way and see what I did there. So A and H is going to project down as well. Always make sure, remember you're using a pencil, so they're construction lines, guys, so bring them down far enough, or as far as you think you might need them. Okay, don't think D and E have to come down too far, and same with F and G. Something like that. Okay, now at this point I want to find those points. Okay, so I'm going to start with the furthest ones. So I'm going to start with A and B. So A is there and B, they're both the same distance down from the x1, y1, okay, or from the xy line. It's because remember, projecting from the elevation, take our distances down to the plan, xy line down. So get the distance for A and B there. So A is followed here and it's out here to the x1, y1. So there's A1, and then I want to find B. It's the exact same distance out. And there's B1, once again labeling A1, B1, and now I'm going to take the distances down for C and D. So there's C, now I want to find C1 and then D1. Just make sure you need to bring out this line a little bit further. Once again, C1 and D1, and now the next one is E and F. There's E. Now I'll find E1 and F1, and they just worked out fine. E1 and F1, and then the last one is going to be G and H. As you can see, guys, it's a little bit awkward. G there. So find G. And then H. It's back down here. So G1, H1. Okay, I can connect all of them up. Okay, and as you can see there, guys, what I've essentially found is the true shape of the cut surface A. Okay, now what we'd actually have to do here is complete the rest of it. Okay, and obviously there we'd see a bit of this face, because when we're looking in this direction, okay, we would see, if you look, I'm just going to leave the borrow there so you can kind of see it, looking roughly perpendicular to it, you would see a bit of this face here. Okay, so that's this bit here, we can see a bit of that. We would see all of this running back here, which is all this here, and then we would see a bit of this as well. Okay, you have to remember we're looking down on top of it kind of at that angle, okay? So we would see that kind of rough shape there, this bit here and this bit here, and then there's going to be a bit of hidden details. So there's a little bit involved in this now, alright? So the first bit, we're just going to break it down block by block, okay? So I'm going to start with this little bit up here. So we've got this point, these 2 points. What we actually have to find now is, we have G and F, we have to find this one and this one, okay? Which is here in this position in our elevation. So very simple, we're just going to project it down, okay? So project it down, it was that point there, I'm going to project it down. Okay, and we know that this point here and this point here are the same distance out as G and F. So what I could do is, I could literally just do a bit of sliding set squares, and where G and F was, I could just mark them there and there, the same distance out. Okay, and what I'll do is I'll just heavy in that bit, because we would see that. Okay, we're getting onto the points here now where we're trying to save ourselves a little bit of time. So there's that bit. I've now done this bit here. Okay, now the next bit I have to work on is this bit. So I have E and D, and I know E connects to this, and this point connects to this, and D connects to that. Okay, so it's just a case of finding those two. So we can see it's this one here, and I kind of have it there. It's pretty close, and just make sure I get it exactly. It's probably just off at about 0.5 millimeter, so I will do another line down just in case. Okay, and we can see we've got one point there, and the other one, D, this point here, okay, this point here, D, which is here, is the same distance out as this one, which is there. Okay, so obviously with D, then I can just extend D on. Okay, and as you can see, it's starting to take a little bit of shape now. And what we've got is, we've got this top surface, we've got this surface. Now what I'm actually going to look for, okay, is this kind of surface here, okay? And the most important point I want to actually find is this point here, right at the back, okay? So that point there is here in our elevation. So, to find that, take it down, take it in blocks, break it up and make it easier for yourselves. Check that down, okay? It's the same distance out as B was, so B is going to go back, and there we've found. It goes back as far as there. Now, this is where it can get a little bit tricky, okay? This bit here runs all the way back. I'm going to put it in here, just in a little bit of red. It doesn't stop here, it keeps going, and it's going to go back. And it's actually going to go back where this one comes down and meets it here, okay? So I'd imagine then we probably have a little bit of detail in here as well. That will go back, and then they will connect up there like that, okay? And technically, there'd be a little line running down there as well, okay? Of that back face there, of that piece. So that's probably, you'd have to have kind of good visualization to be able to understand that. So we'll try and put that in now. So I know this one is going all the way back to here, which is where that face is coming down. So it's going to go all the way back to here. So I'll heavy in this bit. And then technically, now depending on my accuracy, I've got hidden detail there. Okay, and that's the back face there. And now what I have to do is I have to find this bit here. Okay, and that'll actually be the question completed then. So that bit went all the way back to here. Okay, and I'll have another little bit of hidden detail down at the bottom in a second. I'll put that in at the very, very end. But I've got this bit here to put in. Okay, probably won't see that one actually, because we might see it a little bit. So what I'm going to do is I got to find those points, which is basically here off this line. So project them down. Alright, and at this point then, so it'll come down just a little bit there. Alright, so what I got to do now is, that face there at the back, as we can kind of see that square structure there at the back, we need to put in that. There's going to be hidden detail there like that, okay? And that hidden detail is just going to be from here to there, and then from there up. Okay, there's a little bit in that, little bit confusing there, okay? And now the last little bit on this question, okay, is at the very back corner here, at the very, very back, technically that runs all the way to the back over there and meets up with this guy at the back down here. Okay, we kind of have an L structure at the backs, but definitely this line here at the back, we need to put that in hidden detail, and that point there is this point in our plan view. Okay, so once again I need to project that down. Sometimes it's just a case of working these things out. Check that down. And I'm just thinking, yeah, that actually runs all the way to the edge of it. Yep, there we go. And once again, what I'm actually going to do is just quickly, I'm going to shade in the true shape of that surface A there, okay? So just very quickly, I'm going to speed up the video there now. And there we go, we have the true shape of the surface A just kind of shaded in there, and we can see the top surface here, which is this bit here is here, and then this bit here is running along the back, and then it goes around the back and then up, okay? Little bit in that there, guys. Often I'd use a little bit more colours maybe in class to help me understand the students a little bit more. But that's the question there done, guys. Hope you found that helpful, okay?